Okay, so the last video for locating roots is by using a specific formula called the Newton-Raphson formula. And it's just another example of an iteration formula, which we looked at in the previous video, but it's just got a specific form. So as you can see, xn plus 1 is xn minus the function over the derivative of the function. So we're going to need to differentiate the function and put it in the denominator. One key point or tip they could ask you is, when will this formula not work? And that's when the derivative f prime of x is equal to 0. So if an x value makes the derivative equal to 0, then it won't work, because we can't divide anything by 0. It's on the denominator, right? So that's the one mark question that they could ask you, or it's a common question that they can ask you. Okay, so let's try a question. So we have a function learn 3x minus 4 minus x squared plus 10. Show that f of x equals 0 has a root alpha in the interval 3.4 and 3.5. So this is just an example of the first video we're looking at, where we're locating roots, where we have to find a sign change, right? So we just plug in 3.4 and 3.5 into the original function, and then we just say, oh look, there is a sign change. I'm not going to plug it in, but there is a sign change, right? And then we can say that there is a root in between 3.4 and 3.5. Right, B, find f prime of x. So they've asked us to do this because we're going to need it in the Newton-Raphson formula. So this is just using differentiation. This one should be fairly simple. So 3 over 3x minus 4 minus 2x, like this. C, taking 3.4 as the first approximation, apply the Newton-Raphson procedure once to f of x to obtain the second approximation for alpha. Okay, so our Newton-Raphson formula was xn plus 1 is equal to xn minus the function over the derivative of that function. So xn plus 1 is equal to xn minus f of x is the ln 3x minus 4 minus x squared plus 10 divided by the derivative which we found in part B, like this. And it said that x0, the first approximation, is 3.4. So x1 is 3.4. So therefore x2, you just have to show yourself plugging in. So 3.4 minus, and then 3 times 3.4 minus 4 minus 3.4 squared plus 10 all over 3 over 3 times 3.4 minus 4 minus 2 times 3.4, and you'll get a value of 3.442. So you just need to show yourself plugging in, and that's about it. It's not too difficult, right? It's just making sure that you get the right derivative, make sure it's in the right form, and then just find your next iterations or next approximations.